All right, welcome to what did we call it? Footage Friday. Was that what we decided on? Today we're going to go over 12.2. We're going to deal with probability, which comes after counting. You have to be able to count to do probability because in order to do probability, you have to count the number of favorable events divided by the total number of possible events. That is my little formula for probability. And we're going to look at a couple of examples here. Let's just jump in. Sample space are the possible outcomes for an experiment. So if I am rolling two dice, then two is in the sample space. The sum of the dice could be two, but one is not. I can't roll two dice and have the sum be a one, at least not normal dice. Okay, so when two dice are rolled, the possible sums of numbers of the upturned faces of the dice are the set of numbers from 2 to 12, I should say, set of integers. Is this an appropriate sample space for the experiment of rolling two dice? No, the elements are not equally likely. So in a sample space, need not be equally likely. For the purpose of it, we'll only work with sample spaces that are made up of equally likely outcomes. So these are not equally likely outcomes, yet each of these things are. It may be inconvenient to draw all the elements of a sample space, so other methods of representation are used. We could, for example, show the 36 elements of a sample space for rolling of two dice in any of the following forms. This is what they're going to call a lattice down here, where each dot represents an element. Notice that there is one dot for 2, one dot for 12, but 6 and 1, 5 and 2, 3 and I said 5 and 2, 3 and 4, 4 and 3, 2 and 5, and 1 and 6 all add up to 7. We could do it in a chart where each box represents the element. We could do it in a tree diagram, any number of things that you've undoubtedly played around with in the past. Okay, let's jump in. Example 1, what is the probability that when two dice are rolled, the sum of the numbers on the upturned faces will be 6? By the way, this is not for public school. In public school, we weren't allowed to say the word dice. All right, my number of favorable events, well, I could have a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, or a 5 and 1. 1, 2, 3, 4, 5. There are 5 possibilities out of a grand whopping total of 36 different possibilities, and that is my probability. Probability will always be less than 1. There can never be a, well, I guess it could be 1. If today is Friday, what are the odds that tomorrow is a Saturday? 100%, but they'll never be greater than 1. A die is rolled and a coin is flipped. Find the probability that the number on the die is even and the coin shows heads. So I could write these all out. There is a 1 with a heads, a 2 with a heads, a 3 with a heads, a 4, a 5, a 6, also a 1 with a tails, a 2 with a tails, a 3 with a tails, a 4, a 5, and a 6. Thank you for bearing with me on that. Out of all 12 possible events, there are, what were we looking for? Even and heads, so this one, that one, and that one. And 3 out of 12, which of course reduces to 1/4, or if you prefer, a 25% chance. Now, could we have done this quicker? Undoubtedly. What are the odds that the die is going to be even? Well, 1/2, 3 out of 6, and the number on the, the coin is going to be heads, also 1/2. When you multiply probabilities, technically it's called folding them. This time, half the time And for every half of those times, half of that time, all of our favorable outcomes will appear, and we'll end up with a probability of 1/4. Okay. A bag contains 6 red marbles and 5 blue marbles. The marbles are drawn at random from the bag. Find the probability that all 3 are red. Okay, so for this one, the chances that the first one is red is 6 out of 11. The chances that the next one is red is there are now 5 remaining red marbles out of 10 remaining marbles total, and we have a 4 out of 9 for that third one. Seeing if any of these things reduce, that certainly does. So I'll make that a 1 and a 2. These reduce, I'll make that a 3 and a 2. And it looks like we have 8/66. That looks good to me, which can I guess reduce a little bit more? 4 and 33. If I were wise, I would have seen this before we got going. Okay, so not much of the time will you end up with all marbles being red. 5 cards are drawn at random from a standard deck. Find the probability that 2 are hearts and 3 are spades. Okay, so what I'm going to do is I am going to first look at the sample space, and this is the number of ways which I can pull 5 cards from the deck. So do we care about order here? I would say no. So there are 52 cards in a deck, and I am choosing 5 of them. On the top, there are 5 cards are drawn from random from the standard deck. Find the probability that 2 are hearts. So there are 13 hearts, and I am choosing 2 of them. And we have to have 3 are spades. So again, 13 spades, and I'm choosing 3 of them. So I think that is going to be our solution for example 4. And let's continue on. 5 different cards are drawn at random, 1 at a time from a standard deck. Find the probability that the selection consists of 2 hearts and 3 spades chosen alternately. Okay. So the first card there are 13 different spades that I'd have to pull from. Then on my next card, there are 13 different hearts to pull from. Then there are 12 and 12, and finally 11. Okay, here there were 52 cards, 51, 50, 49, and 48. So there it is. A lot of these things reduce if we actually wanted to put it all together. For example, the 12 and 48 is 1/4, the 13 and 52 is 1/4. Hey, 2 numbers between -1 and 1 are randomly chosen. Find the probability that the sum of their squares is less than 1. Holy cow. Okay, that is a good question. In fact, I think that is good enough that I'm going to have to pause and contemplate this one a teeny bit. So I am going to do so. Okay, I have some thoughts here. So my first thought is I'm going to draw in this guy, which goes from 0 to 1 and 1. So really, this is my first number. This is my second number. And I am thinking here, so do bear with me. Going to continue to pause and ponder. got ideas. Now, by the way, the reason I went from 0 to 1 instead of from -1 to 1 is it's the same thing. I'm squaring these numbers, so it doesn't really matter, just like it didn't really matter when we were looking at dice, whether we were calling it 1/2 or 3/6. It doesn't matter whether I'm looking on this side or this side. Okay. I'm getting a message from another one. Okay, I think I got it here. And it actually wasn't all too bad. It just required a little bit of my geometry. I thought about x squared plus y squared equals 1. Oh heck, that is the formula for a circle. I guess I am going to end up drawing the whole thing in after all. So there is 0. Not that it makes any difference, because this is literally 4 times as big and won't really change the ratio. So I find that some of their squares is less than 1. That would be in this area versus in the whole area. Well, the whole area is a square, which is a 2 by 2. So out of 4, and we've got the area of this guy, which is pi r squared, pi 1 squared, pi. So that should be it. And that wasn't nearly as hard as I was making it. And I think that was the last one, is it not? Yes, it is. Okay. Well, enjoy. Have a good weekend, and I will talk to you soon. Bye-bye.